All right, let's take a look at a few of these off of the I can write and solve equations with variables on both sides. So when it comes to number 2, you have 1, 2, 3, 4 correct choices on how you could start this problem. And that's the funny thing about this is there isn't one right move, and that's, I shouldn't say the funny thing about this. I guess that's the point of doing these is you have to make that call. So I'm going to pick what I think makes the most sense for me, and I'm going to subtract 2u because I know that it's a practice of some people that they move the variables to the left side. And so I did that. And now I have my variable right here, and I'm going to leave it there and move this 3. So negative 10u equals negative 20. And then, as you might expect, I'm going to divide by negative 10, divide by negative 10, and get that u equals 2. All right, I'm going to slide down here. Let's do, how about number 6? Okay, so number 1, I feel like there was lots of options, and I didn't write PEMDAS down. So I guess let's reflect on PEMDAS real quick. Back up here, there was absolutely no simplifying that could take place. The left side is simplified, the right side is simplified, so you're ready to solve. Down here, though, I can't do what's inside the parentheses. I don't have any exponents. I can multiply. So I'm going to distribute that to the negative 2, and I get negative 2x. Distribute there, and I get plus 8. Distribute here, I get 7x. Distribute here, negative 28. And now we're back in this boat of, hey, pick which one of the 1, 2, 3, 4 options you have. And now I'm just going to pick kind of a random way to do this. I'm going to subtract 8. Actually, I guess this doesn't really end up being so random because in doing that, I'm going to end up moving the variables to the left again. So subtract 7x. But maybe I just started in a way that you weren't kind of expecting. So anyway, negative 9x equals negative 36. Divide both sides by negative 9, and you get x is 4. I'm going to go ahead and do this one just because some people in class thought it seemed to look quite crazy. So here we go, distribute. And why am I distributing? Because there's nothing else really to do. I can't subtract this 3g. I'm not going to move it over here just yet, right? So I'm not going to do that. And then same thing with this side. So 8 times 3g is 24g. 8 times 2 is 16. 3 times 5g is 15g. 3 times negative 4, negative 12. All right. These are like terms, so that's 21g plus 16. These are like terms, so that's negative 14. And now we're back to this scenario and to this scenario. We have 4 choices. So now I really am going to just do the different thing. So how about this? Let's add 14. I said do the different thing. Basically what I'm doing is not what I would normally do, which is to move the variable to the right. And I get 30 equals negative 6g. Divide both sides by negative 6, and I get the g equals negative 5. These top 4, not any more difficult than the others, but I want to focus on this one real quick just because I'm going to do it in a way that maybe you aren't kind of expecting. I am not going to distribute that 1/3. I'm going to get rid of it. So what I'm going to do is I'm going to multiply this entire side by 3. And if I multiply one side by 3, I got to multiply the other side by 3. So how this works is right here, that 1/3 times 12 minus 24v is kind of like saying 2 times 3. It's one number times another number. There's the one number times this quantity, which is one quantity, okay? So if someone comes along and says, hey, what if we multiply by 4? Then it's 8 times 3. And if you're like, what are you talking about? So check this out. 3 times 1/3 is 1. So really I have just this left over, 12 minus 24v. And then over here, I'm going to distribute that 3 to right here, and I get equals -6 times this quantity right here. So I guess maybe right here, it might seem like it, I'm sorry, here kind of seems like what happened here of I have one quantity times another quantity, and that was this part. So when I bring in this number, that's technically this number, and I just multiplied 2 of them. What about this? Could I have done 4 times 3? Yeah, I would have gotten 12. And guess what? 12 times 2 is 24, and so is 8 times 3. Multiplication is commutative, is what that means. So anyway, I just did it that way just to kind of do it a little differently so that maybe you could go, oh, I see, we could have done something like that. So the reason that these are not any more difficult than the other, but do have a twist to them, is, check this out. Now I subtract 12, and that's interesting. The 12s cancel on either side, and I get -24v equals -24v. Wait a second. This side is identical to this side. That means no matter what I plug in for v, I will get an answer. So the answer is either all real numbers, or you could say it's infinite, or there's a little infinity symbol. Boom. That's how number 10 works. And in fact, one of these has a no solution answer, and I'll go ahead and give you a hint. When you get a no solution answer, it means that the left side, like 3, equals 7. That could never happen. 3 is not 7, so that's why it would be no solution. Down here, let's see. I guess I'll go ahead and do 13. I'll start 13 with you. The table shows pricing information for 2 pizzas. How many toppings would make the costs the same for both pizzas? We touched briefly on independent and dependent variables. So the price of pizza A, I'm going to do like PA for pizza A, is $10, because there it is. And then we can add $1.50 for every topping. I'm going to use a T for topping right here. T for topping. So here's what's going on. This independent variable is right here. And then this dependent variable is right here. The price of pizza A depends on how many toppings we get, okay? Well, guess what? The price of pizza B is $12.50, and then we can add $1 per topping, which I will never really write 1 in front of my variables, but I did in this situation just because it's 1 right there. So here's what they're wanting to know: how many toppings would make them pizzas cost the same? So what we're going to do is set these two equal to each other, and we get, let's do it out over here. 10 plus $1.50 per topping is equal to $12.50 plus just 1 topping, which in theory it's $1 per topping. And now this is where I'm going to leave you to solve it yourself. And last thing is, I'm going to come down here, and I imagine you're going to ask me about 15, and so I'm going to save that for later. I'm just going to remind you how to do 14, and I'm not going to finish it, because again, it will be as difficult as like this problem once you get it all set up. The sum of 4 consecutive even integers. So 10 is an even integer. The next even integer is 12. The next even integer is 14. The next even integer is 16. If I wanted to add these up, I would just, add them up, duh. But what if there were numbers I didn't know? Like, I don't know what that number is, but the next even integer is 2 more than it. And the next even integer is 2 more than that one. And the next even integer is 2 more than that one. And if I add all of them up and I get 100, x plus x plus x plus x is 4x. And 2 plus 4 is 6, plus another 6 is 12, and like we just said, it equals 100. And that's where I'm going to stop for this video, because I believe you can do it. Let me know what questions you got.